Hi, welcome to Know Your Adversary. We're exploring open source contributions with attack path management today with Christopher Maddalena. My name is Justin Kohler and this is Jared Atkinson. So open source contributions and just open source ethos is kind of core to SpectreOps. But can you talk a little bit about open source contributions to kind of the project attack paths in general?
Yeah. So we've been looking at the past year of what's been contributed specifically to attack path management. And what we've seen is that a lot of things that are in some cases old news, like file share triaging, has been a problem forever. Looking at GPOs, it's been a problem forever. There's still been some cool stuff that came out in the last couple of years, like Power Hunt shares and GPOHound. But what's evolved is making that stuff kind of like you both talked about in an earlier episode on it's like BloodHound in general, of how we came from trust visualizer and pivot tables to something that's like a graph that's much more easy to use and browse and see, and you can get pretty pictures out of it to put into a report. It makes it much more digestible.
Yeah.
And so if you look at say Power Hunt shares that took again something that used to be a bunch of PowerShell output, a CSV file that you'd pour over. Maybe if you were lucky, you had a tool that made a little HTML table or something for you to go. And now it makes a much nicer looking little HTML application that opens up. Things look really nice. They're styled. It makes it much more digestible. And then even that project started experimenting with pushing that into the BloodHound data. So you could actually have an edge added to BloodHound that said there's a permissive file share or a bad GPO that is adding that edge there, so you can actually find a path through BloodHound. So again, all in service of not really solving that problem. It's not really solvable, but making it so it's much more digestible so that a defender can take that data and actually triage with it and know how to prioritize, and even maybe see that in BloodHound if BloodHound's their interface through which that's their lens that they're looking at all that. Now it all has one home and they can actually see that edge there and maybe understand it better of what is the actual threat here.
So you named Power Hunt shares as one example. Do you see different categories of open source contribution when it comes to attack path, maybe specific to BloodHound, but not just in attack paths in general? Are there different categories? I think of extending the graph as one kind of category. So BloodHound historically was really focused in Active Directory and then moved to Azure, but other people have other things, right, that they want to cover. So that's where KubeHound came in from the Datadog team to explore Kubernetes attack paths. So that would be an expansion of the graph. But then there's also other things LLMs and MCP servers for how to interact with these tools in a way that's more approachable. I don't know how to write a specialized query to find this thing, but I know what I'm looking for, so can I use this new thing to so how do you think about the categories of different contributions? Is there more than two? Or?
I think there's definitely categories, because there's all sorts of research, especially as you start to look at identity kind of, because like you mentioned, we were once focused very much on Active Directory.
Yeah.
And because that was the common denominator across attack paths. If you could get into Active Directory, start getting your hands into things there, you found a way to get places. And then some people would maybe be more focused on Linux tradecraft, if that was the environments they were in, things like that. But you became specialized in one area. But as things have evolved, and now identity providers are much more the edge you're trying to go after, that's a whole new world of research and things to look into. So there's all that happening, and BloodHound has evolved to include Entra ID and Azure and things to adapt to that as well. And I think one of the core themes that I see, looking over the projects they have the last couple of months, is just making that information digestible, making it something that someone can actually understand, both just for maybe the pen tester, the red teamer, the attack, the person that's actually trying to use the data maybe to go do something and prove out the impact, but also you got to hand that over to someone eventually and explain to them what was the impact.
Yeah.
And so that's always been one of the biggest challenges for a red teamer. It's the report is you're the final boss of that assessment of, all right, now how do I actually explain why someone should care about anything I just did?
Yeah, and it's I could say the same thing in a report form or written out, or BloodHound was pivot tables way back in the day, right? But seeing it as a path from A through assets B, C, and D to get to X, right? It paints a different picture. So it's what you're saying is it's more approachable, taking maybe adversary tradecraft that's developed for a Linux environment or an AWS environment and graphing it so that more people can understand that. Yeah, that's really cool.
And being able to draw the connections between them, whereas
Yeah.
before it might, you'd be talking about protocols or things like that that people wouldn't understand. It's like being able to show them in a graph. Like, no, here's how they connect. Like, okay, well I can see, like basically like following GPS directions.
Yeah.
Versus giving them someone like, yeah, go down there, you turn left at the big oak tree, and then you'll know it when you see it. It's like if I can just show you on a map,
Right.
it's much more easy to digest and like, okay, that's where I go. That's how you got there. And like you mentioned, MCP servers. Those, we have seen people move like LLM into like BloodHound or just in general like attack path tradecraft, trying to bring that in. I mean, you get into different areas of research there too, where people have just like hooked up LLMs to like Mythic C2 and had it operate an agent completely autonomously just to see what it would do or to give it instructions and have it try to work through a lab. But also we have like these, there's been a couple of BloodHound MCP servers that opened up over this past year that are trying to make it more approachable to become like a power user of BloodHound.
Yeah.
Whereas historically, if you wanted to be a power user, you're writing your own Cypher queries, and that can be pretty daunting to understand how do you actually write this query out. Or, for example, there's been lots of projects. I wrote one years ago, and there's been a ton of other that like Walter Legowski and others have made of like interfaces to BloodHound, where you can try to ask it questions, or it had built-in queries, whatever, or to pull out some of the data that wasn't in the graph exactly. Like if you just wanted a count of domain admins, it'd be like a really simple data point. You couldn't see that in the graph easily.
Yeah.
You'd go into like the Neo4j console and actually run the query and pull out like, okay, here's my CSV file of how many domain admins, how many groups, or how many people are in this group, et cetera. And so people made interfaces into BloodHound to get that data. Because at the end of the day, again, getting back to that, making things more digestible, BloodHound, even if you didn't even necessarily need the graph, like just BloodHound's like, well, I have a database of everything in Active Directory. If I just want to pull out a data point from my report where I need to know something, much easier to query the BloodHound data I already have versus trying to find that in Active Directory.
Totally. And I think another example of like the MCP server, you mentioned like BloodHound queries or Cypher. But like it could apply to anything, right? Like that's why people are really excited about using it with like KQL for Sentinel or you name it, right? A lot of people don't have the time to dedicate to like understanding how that works. Now the projects there are really exciting. We're exploring some of that internally here at SpecterOps on how do we use kind of like LLMs and natural language or like generative AI to enhance BloodHound. Just as an aside, when you use those, be careful because they can generate queries that function or return, but they actually don't look for what you think they're looking for. So it does help to have that background knowledge. You can't totally trust it. You have to be able to read and kind of decipher what it's saying the query is doing.
It's a tricky subject just because you're also getting to the fact that you're giving, you want to be careful around, you're taking, unless you're working in a lab, sensitive like Active Directory data and exposing it to a third-party LLM.
That's a big disclaimer, right? I mean, before you use some of these, make sure you understand where the
that.
data is going.
Because like what we're talking about, we didn't quite say before we get into that topic, like the MCP servers, like one thing they're doing right now, and I'm sure they'll mature and change, is that one of their primary goals today, as they exist today, is making it possible for you to go to like Claude desktop or something and say, hey, how do I get from like point A to point B in this BloodHound data? And then it's creating the query, it's going in there and it's finding it for you if you didn't know how to actually write the Cypher query with the right filters or whatever to filter down your attack path to see that rather than just clicking like show me shortest path. And that's really, really cool. But like you said, like, it could be a Cypher query that, one of the jokes when you get into like vibe coding or whatever, like you're asking an LLM like, hey, can you write me this Golang function that does this? Eventually, you might be like, all right, I need you to process an image and then give me out the, output this. And it's like, well, no, that didn't work. Please try it again. And eventually you get there and you're like, wow, it works. This is amazing. And then you see that the function is like just at the end, it just outputs the same image every time. It's not actually doing the processing.
So it helps to have some of that background knowledge on the exploring the graph or expanding the graph, right? So we've taken this internally, right? Like primarily your team is expanding that graph. And we've seen other teams do that in different technologies. So whether that be BloodHound or the file share stuff out of NetSpy, kind of expansions too. But part of that was because of the difficulty of getting it into BloodHound, right? Like, and I can say this on our side, the schema was very focused on what we looked at as Active Directory data versus Azure data. It wasn't just like a generic schema, which caused a lot of problems, right? Like when we talked to the Datadog folks, they were saying that they wanted to get it into BloodHound, but they couldn't. It was just too difficult.
Yeah, I think it's obvious from the name, right? BloodHound, for instance, that there was some inspiration related to BloodHound. And they had told us that there was interest in getting it into BloodHound, but it was just too onerous of a process to actually go through the integration steps, and we understand that. And so then the kind of the troublesome part of that is then they end up having to create the actual application that's going to view the graph and display the graph, and that's first of all a waste of resources, right? To have to do all that. But also you lose the ability to interconnect everything, right? So whether or not BloodHound or PowerHunt shares or whatever was tightly integrated into what the existing graph schema would have been, PowerHunt shares probably more likely because it is Active Directory based authentication, right? If you extract that from kind of what we call like the global graph, then you're losing those hybrid paths or those interconnected paths that allow you to see how the compromise of one system facilitates the compromise of this other system.
Yeah, so like just to put a really fine point on it, if we developed another tool to analyze AWS attack paths, but that was completely separate, we would have to duplicate all the work to have the front end and like the visualization, but we would also miss out the connections between maybe AWS and our on-prem or our Azure cloud. Like you don't get that visibility because they're not in the same tool. And that's like, again, that was a friction point previously. It was just too difficult.
Yeah, and I don't know that everybody agrees with me on this, but I watched this, there's this documentary on Netflix about TerraVision, which eventually became Google Earth. And one of the things that they really focused in on was the ability, if you've opened Google Earth, you start with like a picture of the globe, right, the Earth, and then they have the ability to like infinitely zoom in until you get to, they probably didn't have Street View at the time, but imagine that it goes from, you see the entire Earth all the way down to Street View, and you're changing the granularity or the level of focus. Imagine that exists in this graph to where you have the Active Directory graph, you have the Azure graph, but then you zoom out and you see like the continental graph, right, which shows the relationship. Like what are the pathways between Active Directory and Intra? What are the pathways between AWS and Kubernetes? Maybe you're using AWS IAM to manage the identities that are interacting with Kubernetes.
Yeah.
And it's interesting just to look at Kubernetes. What are all the different ways that people can manipulate the aspects of Kubernetes to take control of a cluster or something along those lines? But it becomes extraordinarily interesting when you see that there's a relationship between Active Directory and AWS, and then there's a relationship between AWS and Kubernetes, and those kind of like interstate highways, which are connecting those. That's almost like the first problem that you should solve. Maybe they're there on purpose, maybe they should be there, but you need to be aware of those. You need to take stock of those, and you need to understand like maybe where unintended consequences can come from.
Yeah, and like I can't emphasize this enough. Like the looking at it one technology at a time really doesn't give you the whole picture. I mean, we don't even do that BloodHound doesn't do that in Active Directory, right? It doesn't just look at Active Directory. It's looking at Active Directory and local host permissions. So because the two combined really show you privilege in a Windows or an on-prem Active Directory environment. So you can't just trust the domain controller. You also can't just trust the host. You have to put the two together to really understand the true risk. And so the same thing with Kubernetes. Like we were looking at some early work in Kubernetes attack paths, and we actually brought on our infrastructure engineering team to this discussion. It was really cool. They use Kubernetes every day to maintain our infrastructure, and they were saying, if you just look at Kubernetes, that's cool, but we use Kubernetes in AWS. And so like that's only part of the problem. You have to understand the IAM rules that we're using in AWS to control Kubernetes. Like, so it's super, super important to understand how those systems cross, which I think is why we're so excited with the recent announcement of OpenGraph, right?
Yeah.
Which like not only expanding into new technologies, but like existing open source contributions, like I can just contribute faster. You want to?
Yeah. So I mean, OpenGraph is as the name implies, it's an open schema that allows you to ingest arbitrary data into the BloodHound attack graph, right? And so we've had a lot of opportunities and a lot of success in how we've actually implemented that. In fact, one of the founders of BloodHound, Andy Robbins, told me that OpenGraph is the thing that has made him the most excited about BloodHound in the past 5 years. So that's a really kind of strong idea, which is internally. Justin mentioned my team is constantly doing research to find new tradecraft, to explore new platforms and the different attack graphs that are encompassed by that, right? But then they previously had to turn that over to engineering, who then had to go through this entire onerous process to integrate all of that into the graph. Now, engineering is building the capabilities for OpenGraph, which then basically pushes down the ability to the researcher to be able to actually implement it and see the results immediately. I think that's the actual cool part. One of our researchers was looking into MS SQL, threw all the data into OpenGraph, and then actually found a new bit of tradecraft, a new primitive for privilege escalation that basically was because I was able to visualize this in the graph, I was able to see an obvious problem that otherwise maybe wouldn't have been something that I would have stumbled upon, because it just literally showed up that there was, this thing had a relationship with this thing, which had a relationship with this thing. It's I can traverse that.
Yeah.
And so then it became really cool.
And that's kind of the dream, right, of what that can enable.
Yeah.
Because you're talking a little bit about right, if you make, say, KubeHound in its own application, you make AWS Hound in its own application, not only have those engineering teams duplicated a bunch of effort, and if we made all that, then it's just all right, well, we fix one bug over here, let's fix all the other ones, because it's definitely just almost copy paste for the UI, everything, the back end is probably all the same. You're duplicating a bunch of effort. But then the users are also duplicating much effort, because they have to all right, I'm looking at 80 over here. Well, what if I did want to go to AWS and back? All right, let's go to AWS Hound, and then you're trying to connect it yourself and doing extra work to see if you can find what would connect the two. Like you were saying, to use the Google and Earth analogy, if you were trying to think, all right, if I'm in the US and I want to visit Africa, how do I get there? Well, it might be that you have to jump over to Canada. Actually, I can get a better flight out of Vancouver, go to that international airport, then I can go to Africa and back. That's as much easier. So if you kind of look at that, oh yeah, you can look at just the United States and the interstates, and how do all the states connect, and that's all very natural. And all right, well, Canada's right there. I don't know, Canada's Azure. Oh yeah, there it's all Microsoft. I can go up to Azure really easily. But how do I get over to AWS over here? Oh well, I can actually, if I go to Azure first, you can see those edges much more easily. You can visualize it. And then the dream would be not only that, you found new tradecraft along the way, because now you can actually, it's the first time you could actually see it in one continuous path.
Yeah, and it doesn't interrupt, Jared, you had an example recently of so before we publicly announced OpenGraph, we announced it internally because we wanted to have our research team kind of put it through its paces and see what they could come up with. And I think we're kind of blown away at what people came up with. We didn't realize it was going to be that fast. I'd actually explain the recent example we had.
Yeah, sure. So we're looking at, one of the things that we find is that it's actually much simpler to just do the research on platforms that we use internally at SpectraOps, just because you don't have to go through the process of obtaining a license and all that kind of stuff, because we already have it. And so just kind of playing around, one of the applications that I looked into was 1Password. So imagine that this is a password vault where we store passwords for all different kinds of resources. And as an attacker, if I can compromise 1Password, I now have the ability to kind of fan out to all kinds of different systems, right? And as I was looking into that, I started at 12:30 in the afternoon, and by 2:30, I had already built out kind of a basic attack graph that allowed me to enumerate who are the users, what are the groups that they're a member of, what are the vaults, what are the different items, which are the actual logins or the passwords that are in 1Password, and who has access to what, who has the ability to steal passwords. So I had built the collection, which is a little bit contrived and janky, probably not enterprise grade, we'd say. And I had built the actual visualization of the graph in less than 2 hours. So that was that's the level of speed that you're able to kind of gain from digging into.
Now you're on the probably like the point, because you're used to doing kind of this in BloodHound in
Yeah.
general. I mean, just the concept of attack paths.
There's also platform scale issues.
Yeah.
So like AWS is significantly more, I don't even know much about AWS, but I know enough to know that it's significantly more complicated than
Yeah.
1Password. So there's definitely going to be examples to where the access control system is significantly simpler and easier to understand versus other platforms that are just like super convoluted, right?
Yeah.
And generally speaking, what we see are there's like IDPs, identity providers, so your Oktas, your AWS, your Intra, and then there's going to be kind of like service providers, which are things like GitHub, Snowflake, 1Password. I hesitate to say Salesforce because it's probably more complicated than
It is.
Yeah, but like the service providers, there's probably what would you say, like a scale of simpler versus harder, but service providers are going to be significantly smaller problems to take on as opposed to these identity providers, which are like major systems that you have to really dig into.
And you mentioned, Jared, that working with something that you already had, right? And that makes it pretty easy. I also imagine one thing I'm excited to, and hopefully we'll hear about it because it would be an internal thing, but maybe we'll have a client or something that'll do is, we've worked with clients that have like massive in-house custom applications or whole workflows for their specific line of business.
Yep.
That thing doesn't exist outside of their company, but it's also, we've used it on red teams like as our attack path because it is like, hey, go after this thing because this is everything. So if you can get in here and you can compromise this workflow, that's what we want you to do. That's the objective of that red team.
Yep.
Their teams can now actually build an OpenGraph for their thing and actually have that represented.
One of our researchers, Garrett,
super cool.
Yeah, Garrett Foster, he was really excited about the opportunity to literally expand the graph in real time during a red team. So later we're going to be talking to Andrew, and one of the things that he'll talk about is the relationship of how on a red team, how this idea of attack path management expands beyond kind of like the traditional conception of Active Directory and Intra. And so imagine that you're on a red team, you're given some target, which is some system out there, and you don't know anything about it, but there's maybe SSOs being used, maybe whatever, right? Maybe there's a browser cookie that you need to steal. But then once you're in there, there's a bunch of internal resources. It's kind of like, I think of it as like clearing the fog of war in battle, right? Or in like a top-down
RTS strategy game where you're just like searching around.
Yeah, so you're kind of clearing the fog of war. And so imagine that it's like, okay, as I start, and this is a really important part, I've found personally that there's always like a certain amount that you have to get over. Like you need to know users and groups and vaults in 1Password, for instance, right?
Sure.
But like, it doesn't have to be perfect. BloodHound started with, as we said, users, groups, and computers, right? It's relatively simple. As we explored that, we worked with customers. We found, hey, there's things that we're not considering. We're not considering GPOs, for instance.
ACEs.
We're not considering ACEs. We're not considering ADCS, right? So like, there's all these different components, but like, start simple.
Yeah.
And like, in the context of a red team, you can actually start to graph. Like the coolest idea is imagine you're in a red team and you see the system and you're like, I want to go after that thing. You pull up the documentation, you say, okay, it has users, it has groups, it has these types of permissions. Let me build a collector, grab all that data, throw it into BloodHound, and now I have the ability to say, I'm this user in Active Directory. Show me how I can take over this database in Snowflake.
Or like the basic example in Linux, right? Who has SSH access over what resources? And then now I can go from, how do I get from Azure to SSH like control over some Linux host, right?
So okay. So that's even simpler, right? Because that's maybe it's not actually simpler in practice, but it's one edge as opposed to like integrating an entire system,
right?
For instance, yeah.
What we're talking about in OpenGraph is the ability to supply BloodHound with a payload of data that's properly structured in a format that we provide. You can choose icons and colors, so you can give like, hey, this is a user in Snowflake, for example, and then this is a right that they might have over some asset, and you can do that. And you can use edges that we already have as well in the product. So like this is admin access over a computer, for example, and that just shows up. So once you supply the data and it's ingested, you can use it to search for specific nodes. So I want to see like, does this user exist in Snowflake? What access do they have, right? So what resources do they directly control? Or how can I use an attack path to traverse from Jared's account to Christopher's, for example? And they might be in different platforms, but all that works out of the box. Like that's how it functions. Yep. So we're really excited to roll out more coverage. That at first this is going to be very direct relationships or not very complex. So an example of a complex relationship might be an ADCS or a DC sync attack, if you're familiar. But having admin rights or SSH rights or file share, read access, like that's all in scope. Right?
Yep.
So it's super exciting. Thanks again, Christopher, for joining us.
Yeah, thanks for having me.
We'll see you next time.